All right, guys, this is our lesson 3.4 notes on writing proofs. And so let's just go ahead and get started. So today's goal is to analyze figures to identify and use definitions, postulates, and theorems to construct proofs, analyze and construct viable arguments in a two-column format. So let's go ahead and start with our warm-up, which is where we are verifying each statement with the correct property or definition. So if we look at this here, trying to get it focused, there we go. Okay, we are solving an algebraic equation. And so if you look at this, you can see that the first thing we did was subtract 5 from both sides. So our justification is the subtraction POE. And POE means property of equality, so you've done it to both sides. And then what we do is we end up dividing by 3 on both sides, and so that is our division POE. Okay, all right. What's this one? The measure of angle 1 equals the measure of angle 1. Well, if it equals itself, that is the reflexive property. What about this one? AB minus XY equals CD, and CD equals AB minus XY. The only thing I did was flip things around, and so when we just flip it around on the other side of the equal sign, that is symmetric. Here we have this one. The measure of angle 1 is 90 degrees, and 90 degrees is also the measure of angle 2. So I know that angle 1 equals angle 2. Well, of course, that is my transitive property. And then the last one, number 5, I have 4x plus y equals 10, and I know that y equals 2x, so I just plugged in 2x for y. So that is my substitution. Okay, all right, that's it, guys. So let's go ahead and talk about proofs. So we don't have as many definitions today because we're just kind of getting into actually how we construct proofs. And so the first thing when we talk about proofs, we need to understand what a proof is. Now, a proof is a logical argument in which each statement is supported by a statement that is accepted as true. So these supporting statements can include definitions, postulates, or theorems. So we're just making true statements about what we know until we finally get to what we're trying to say is true. And then what we are spending our time on today is a two-column proof. And we've kind of already looked at those and talked about those. And so that's where we have the statements and the reasons that are organized in a two-column format. Okay, so we have the statements on the left, the reasons or the justifications on the right, and that's kind of what we've been looking at anyway. It's just so now we're constructing them on our own. So the format of how to write a proof. Now, there are structures and things to remember. Okay. Now, every proof has certain parts that we need to look for. Okay. So we have the given statement, otherwise known as the hypothesis, right? We also have things that we need to prove, otherwise known as the conclusion. Okay. Um, Also, a lot of times there will be a diagram involved. There will be statements and there will be your reasons, also known as like your justifications, right? So if we are going to like know that all these parts are present, here's what they generally look like. Okay, well, it's a two-column proof, so we're going to do two columns. And on the left, we always start with our statements, and then over here, we have our reasons or our justifications, right? And so we make our list of all our statements, and for every statement that we do, we have a reason or a justification. Um, at the top of our proof, we are always given something, and it will always tell us what to prove. Okay, or I guess not prove, proof, prove. Okay, so let me just make that better. Prove. Okay, so it'll have that at the top as well. And then usually somewhere off to the side here, we have a diagram that we can look at and tell things from and all that good stuff, okay? So again, this is a proof structure of a two-column proof, which is what we're working on today, okay? All right, so there are some things that I need you to remember. Number one, work out to in. Work out to in. So go with the big ideas and work your way into the smaller ideas. Number two, use the diagram. Okay, look at it. Diagram, can't spell. There we go. So use the diagram that you were given and always ask yourself, what does it tell you? Number three, mark on the diagram what you know. Just like on any type of problem we would be solving, mark what you know. It'll help you out. It'll help you think it through. And the last thing that we need to remember is what I want you to think about is I know this, and what does it tell me? Okay, so we're always trying to think how we get to the next step and how we keep going and all that stuff. Okay, so kind of keep these things in mind as we are making our proofs. All right, well, let's go ahead and get started. So let's look at example number one. So you can see the format is there. We've got our diagram, we've got our given, we've got what we need to prove. Everything is already here. Okay, now it says complete the two-column proof by selecting the correct statement and reasons. Now, given Q is the midpoint of segment PR. Now, what does that tell us? That tells us that if that is the midpoint, that those two are congruent, right? And that's what we know. And that's really all we know right now. So let's go ahead and start. So the first thing is what we start with is the given. Q is the midpoint of PR, given. Okay. All right. Now, what does that tell us? Remember, we're working from the outside in, and what we're trying to prove is that segment PQ is congruent to segment QR. Well, if I know that Q is the midpoint, that tells me that these lengths are the same, right? So I know that PQ is equal to QR because that is the definition of a midpoint. All right. Now, just like we talked about yesterday in class, I know the length, and length uses an equal sign, but I'm trying to prove congruence. So if I know that the length is the same, then I can also say that the segments are congruent to one another. And that is the definition of congruence because I've got PQ equals QR, and then I can say that that is also what that means is congruence, okay? All right, so that was a pretty simple proof. We were able to get it done in 3 steps, and so that's kind of what it looks like, okay? So here's the thing. Once a conjecture has been proven true, it can be used as a reason in other proofs. So the conjecture that we just solved and proved and that we have proven above is known as the midpoint theorem. Okay, so now that we've proven that is true, we can actually use that in our work. So the midpoint theorem says if M is the midpoint of AB, then I know that AM is congruent to MB. And we've actually already talked about that, just not in the formal proof way, right? So I know that A and B, and I know that these are congruent if M is the midpoint. And we did talk about that in Unit 1. We just didn't really go into the proof of it, right? Okay, well, let's look at example 2. Example 2 here, it says B, there we go. Okay. All right, so example 2 says B is the midpoint of AC. Well, what do I know about midpoints? I know that they are congruent, right? It says C is the midpoint of DE, and I know that these two then would be congruent. And it does tell me that AB equals CE. So that means that all 4 of these are congruent to each other because BC or AB is the same length as CE. And if that one is equal to that one, then that one's equal to that one, and that one, and that one, and that one, and it just goes on and on. Okay? All right, so there are three givens. C is the midpoint of DE, AB is equal to CE, B is the midpoint. These are my givens, and here's what I'm trying to prove. I am trying to prove that the length of BC equals the length of DC. Okay, so I'm trying to prove these two segments are equal to each other. Now, it does seem simple enough that we're like, oh, those are all equal. Like we kind of know that. So now we have to prove it. All right. And this can be some part of the like challenging part. You're just like, I know that they're the same because that's what they're telling me. This is how we prove it. Okay. So first we start with the givens. B is the midpoint of segment AC and C is the midpoint of segment DE. Okay. So what that tells me is that segment AB is congruent to segment BC, right? AB and BC are congruent. And it also tells me that segment DC is congruent to segment CE. And that is just the midpoint theorem, right? So if I know that these are the midpoints, I know that these segments are congruent to each other, and I know that these are congruent to each other. Now, the next step, it's like partially filling in some of it for you. We're able to say that AB is equal to CE. Well, let's look at this because this is actually one of the givens, okay? So this is a second given. So we used the midpoint theorem to tell us that these were going to be congruent. And now we're kind of attacking this given to help us get down to the proof, okay? All right, so AB is equal to CE, and that's given. So then what else do I know? Well, I know that this means, not segment, sorry, we're talking length. AB is equal to BC, and DC is equal to CE, right? So if I know that, then I know that. And all that is that's the definition of congruence, right? Because if I know that they are congruent, I know their lengths are equal as well. Okay. So then how do I go from here to here? Well, if I know that AB is the same as BC and DC is the same as CE, well, and I know that like I'm just substituting in because here I know that AB and CE are equal to each other, right? So AB I can put in the place of CE because it's the same, right? So all I used was substitution. So I am able to go to substitution. Now, guys, I will tell you that this can be kind of challenging for some students because you're just like, why am I writing all this out? But this is just how you prove things. This is how you write it and how we're, proving what we already know. Okay? All right, let's keep going. We've got two more. So example 3, it says P is the midpoint of segment JK. So P is the midpoint. And what I'm trying to prove is that X equals 2. All right. Well, let's start with what I am given. P is the midpoint of segment JK. All right. That was given. Now, what I also am given is JP is equal to X and PK is equal to 5x minus 8. That was also given to me, not as the statement, but in the picture. So I'm going to use that as well. Now, the next step takes me down to, it tells me that segment JP is congruent to KP. Well, guys, right there, that's the midpoint theorem. Okay. Okay, sorry, I was just looking back. All right, so if I know that these two are congruent, then I know that these two are equal to each other because that is the definition of congruence. If I tell you that things are congruent, I know that they're the same length. That's what congruence tells me. Okay? All right, well, let's go ahead. It tells us, it gives us a little hint, and it tells us that our reason is substitution. So let's just go ahead and substitute in. JP is X, and I know that is going to be equal to 5X minus 8 because that's what KP is. All right. Well, let's go ahead and solve it because we're trying to figure out what x is. And let's go ahead. We're going to take away the 5x, and that's going to give me negative 4x equals negative 8. So this was my subtraction POE. All right, and then how would I solve this? I would divide both sides by negative 4, and I would get x equals 2, and that would be my division, POE. Ta-da! We proved it. We got down there using only true statements. We got down there. Now, again, you might be thinking, Miss Phillips, I did this in Unit 1, and I didn't need all this junk. Fair enough, you didn't. But we're also using what we do know in order to practice proofs, okay? We do know how to do this stuff. All right, let's do example 4. They've left it a lot more open, and we've got a lot more statements to be made. Okay, so it tells me here that point E is between point D and point F. It just says between, it doesn't say midpoint. Okay, so what do we know? We know that point E is between point D and point F. That is given. Okay, now what else did it tell me? DE is 3x minus 1, and EF is 13. And it also tells me that DF is 6x. So it's like making you kind of add more as you go. And again, this is given. It may not have been given in words, but it's given in the picture. All right, so now what I can go and I can go ahead and use this information to help me. So it says DE plus EF. Well, what do I know that those equal? That equals 6x, or I guess DF. Yeah, let's keep it like that. So I know that DE plus EF equals DF. That is my segment addition postulate. Okay. All right. Well, let's go ahead. It tells me, it kind of gives me a little hint that my next step is substitution. So let's substitute in. So I know that DE is 3x minus 1. I know that EF is 13, and I know that DF is 6x. Okay, now it gives me a little hint that my next step would also be substitution. And so substitution here just means that I am replacing, like I'm kind of combining like terms, right? So negative 1 plus 13 is 12. So I'm going to rewrite that as plus 12 because I substituted the 12 in for the negative 1 plus 13. Okay. All right, well, now that I know that, let's go ahead and solve. So I would take 3x away from both sides, and I would get 12 equals 3x. So that is my subtraction, POE. And then I have to divide, and I'm going to divide by 3 on both sides, and I get x equals 4. And that is my division, POE. Okay, now on some of our earlier examples, we like went ahead and flipped this around and said that was the symmetric property. That's not incorrect, but it's also not necessary. So if you want to leave it just like this, you can. So we were able to prove, so actually what we were supposed to do is not prove something. Well, we did, but it said to find DF. So now that I have proven that x is 4, let's go ahead and find DF. So DF is the full length, which is 6x. And so I would do 6 times 4. And so I get 24. Okay, we're going to keep working on it, guys. It might be a little bit challenging, but we will get it. Promise.